Hello, and welcome back to another exciting episode of Mr. Takeda Teaches Algebra. We've been working with quadratic equations for the past few lessons, and now we're going to tackle quadratics by completing the square. Sounds exciting. Completing the square is it's a concept. It's a procedure that we use to help us solve quadratics. Okay, so this is what it is. I'm going to show you how to complete a square here. Here I have an expression, x squared plus 6x. It's not a square. Think of this as something that's not a square number, like 23. What would I do to complete 23? How would I make that a square? Well, I would add 2 to it, right? 23 plus 2 is 25. 25 is a square. Okay, so here's what we're going to do. We take this value. I'm going to take half of this value. Half of b. We're going to call this the b value, right? And square it. Okay, so half of 6 is 3, and 3 squared is and 3 squared equals 9. So I add 9 to that, and then I have a trinomial square. So I've completed the square. It's now a trinomial square. Same thing here. Half of 9 is 4.5. So we're going to do this with a fraction. So 9 halves. Half of 9 is 9 halves. Right? And squared, I'd have 81 fourths. So plus 81 fourths. And I've completed the square. Okay, so now for each of these, it says fact of the trinomial. So I didn't do that before, so let's do that now. Since these are trinomial squares, this would be special product, right? It's going to be x, the square root of x squared, plus whatever sign that is. The square root of 9, well, that was this number here, this 3 that we just used. This one, well, this will be x, in a parentheses, x minus what? Well, it's going to be 9 halves. That's one that we squared over here to get this. But it's going to be quantity squared. That's it. Those are the factorizations. Again, special products. Now we want to solve an equation by completing this square. Okay, so let me rewrite this over here. Now, when I write this time, I'm going to leave like a space over here, right? Now, normally think we have to set it equal to 0. And we don't always have to do that. Eventually, and you'll see why. Okay, so let's complete this square here. What's half of 16? Half of 16 is 8, and then 8 squared is 64. So I'm going to add 64 here. And remember, since we're dealing with an equation, whatever I would do to one side of the equation, I must do to the other. Okay, so now I can factor this into x minus 8 quantity squared, and then 64 and negative 15 is going to be 49. Oops, lost my pointer there, 49. Okay, so now we're going to go back to the previous lesson and use a strategy that we learned last lesson. We're going to take the square root of both sides. So if I take the square root of x minus 8, x minus 8 squared, I'll have x minus 8. Let me say that one more time. If I take the square root of x minus 8 squared, I'll have x minus 8. I must also take the square root of 49, but again, I'm going to have 2 square roots, so positive and negative 7, because 7 times 7 is 49. Negative 7 times negative 7 is also 49. Okay, so now I can add 8 to both sides. So x will equal 8 plus 7 is 15. 8 minus 7 is 1. And those were our 2 solutions there. Okay, that's solving by completing the square. We want to solve this one by completing the square. 2x squared plus 20x minus 8 equals 0. We're going to solve this by completing the square. So the first thing I want to do here is we got to this time we have to clear out this space, and because this is not a square, so I'm going to clear out that that last space over here by adding 8 to both sides. Okay. Now I can divide everything by 2. I can reduce it down. I could have done that on this step, the first step as well. But x squared plus 10x equals 4. Reduce everything down. Now I'm going to complete the square here and add the same thing to this side. So now it's just like the problem we just did. Half of 10 is 5. 5 squared is 25. Okay, so the factorization of the left side is x plus 5 quantity squared equals 29. And then if I take the square root of both sides, I'll have x plus 5 on the left equal to the positive and negative square root of 29. And if I subtract 5 from both sides now, x will equal negative 5 plus or minus the square root of 29. And that's it. And if you use the calculator to approximate these, you're going to get approximately 0.39 and negative 10.39. But this is an exact answer, and I actually kind of prefer this. So depending if it's a word problem, if it says to estimate it, we'll do this. If it's a word problem, you'll probably need to do this. But if it's just a straight-on math problem, I'm going to prefer an answer like this. But you have to get used to looking at it both ways because, again, a lot of tests that you take will be multiple choice tests, and they might have the answer one way but not the other. So you have to get used to going back and forth between two worlds here. Okay, let's take a look at minimum and maximum value. So here I've got this quadratic equation, and we're using the y now. So minimum value, what about minimum value? Minimum value involves a positive parabola, right? So minimum value. And that's okay here because this is a positive parabola, so this looks like it's going to work okay. So we're going to do this by completing the square. So what I'm going to do here is I'm going to get rid of the negative 1 over here so I can complete the square over here. I'm going to add 1 to both sides. So this becomes y plus 1 equals x squared plus 4x. And then to complete the square, half of 4x is 2. 2 squared is 4. I'm going to do that to both sides. So let me simplify here before I move on. So y plus 5 equals x squared plus 4x plus 4. Okay, and then we're going to factor this side into x plus 2 quantity squared. And now if I take the square root of, actually I'm not going to take the square root of both sides. I'm going to just subtract 5 from both sides here. So I'm just solving for y because that's all I need to do here. So y equals x plus 2 quantity squared minus 5. And so we have this equation now, which is in vertex form, right? Remember, it was x minus. So my vertex, I can look at this and see that my vertex is at negative 2, negative 5, right? Because it's minus negative 2 and plus negative 5. So negative 2, negative 5. So my minimum value is the y value. So the min value equals negative 5. Okay. And this one, I'm going to do this part way. I'm going to do this part way, but not all the way. Since they're asking for a maximum, we have a parabola like that, of course, and that matches up with this. So what we want to do here is subtract 7 from both sides. Okay. And then the important thing with this one is, I'm not going to finish the whole thing here to save video time, is before we complete the square, we factor out that -1. So this becomes x squared minus 2x. Okay. And then when I complete the square now, I'll have x squared minus 2x. Half of 2 is 1, and 1 squared is 1. So I'm going to add 1 there. And because this is really -1 times 1, what am I going to add to the other side? I'm actually going to add, I should have left room here to do that. I'm going to do this in color here for you guys. Y minus 7. This is -1 times 1 that I put in there. And let me just put this in red so we can see our changes here. There. Okay, remember this is -1 times 1, so I have to subtract 1 from this side. So I have y minus 8 equals -1 times x squared. Okay. I wasn't going to finish this, but I guess I'll go ahead and finish it here. Y minus 8 equals -1 times, this would be x minus 1 squared. And then I'm going to just go ahead and add 8 to both sides. So y equals -1 times x minus 1 squared plus 8. And so we can see that my vertex here is at 1 and negative is at 1, 8. Sorry, 1, 8. So the vertex is at 1, 8. So my max value is 8. I went ahead and did the whole thing because it's a little bit different. So I'm going to make sure we talk about that, have that on the video, and that's it. So study hard. All right, and I'll see you in class next time. Bye.